Okay, good morning everyone. Welcome back. Let's get started. So last time we talked about the organization of electricity market briefly. So we discussed what's the difference between general commodities and electricity. The first one is electricity is inextricably linked with physical delivery system. So this electricity is not same to other goods, commodities like wheat, flour, what else? Cocoa, rice, oil, etc. And also in electric market, you will see a centralized market, which is based on pool, electricity pool. So all the generators are connected to this pool, and all the loads are connected to this pool. Okay, so there's another difference. And about the demands, in power system economics, the load forecasting is used a lot to predict daily or weekly or seasonal load variations. So one of you guys do this load forecasting, and also these days renewable generation forecasting. And also electricity has very low price electricity, which means that the load consumption is almost not changed by the price. That's the difficulty. But these days, the demand response becomes popular. So this is a traditional perspective. These days, demand can be responsive. So today, let's talk about the trading period. So how long should they be? The transaction can happen for 1 hour or 1 day. And also, it can be made real time in spot market or in advance, like day ahead or months ahead or season ahead. Okay, so how long it should be and how long it should be made in advance. And because in chapter 2 we talked about forward markets, we will visit this forward market also. So to reduce the risk, the forward market exists. But when there is a mismatch in the forward market, then those quantity need to be sold or purchased in the spot market in real time. Okay. So let's first talk about the spot market. And the reason why we need to have a spot market is because, from the demand side, the load forecasting always has some errors. Okay, of course, when we aggregate all the loads in Korea, for example, the error percentage is just 2% or something like that. But anyway, there is a load forecasting error, and the mismatch of that can be compensated at the spot market. Similarly, in the supply side, suppose that you are generators, you want to participate in the electricity market, and you commit to deliver some amount, like 1 gigawatt or 500 megawatt, blah, blah, blah. But this gas turbine, or anyway, the generator is made of turbine, okay? And sometimes this mechanical system can break down unexpectedly. Okay, so in the case you cannot supply your committed generation, and you need to buy that amount of power from the spot market and sell it to fulfill your requirement. So the spot market is the one where the supply shortage or the demand forecasting error can be compensated. Okay, and we want to do that quickly. So gap between load and generation must be filled quickly. So here is the question: can we use market mechanism to compensate this gap between load and generation in real time in spot market? That's not possible. Okay, so spot market is too slow for electricity, and it may be too expensive because it requires a lot of fast communications, and also they should affect a lot of market participants. So what we want to do is we want to minimize the total amount of power exchanged at the spot market. Okay, so spot market is the last resort, 최후의 수단, to balance the power generation and load. So by using a forward market, we can minimize the total volume that is traded in this spot market. So that's why we talked about forward market in advance. And there are two types of forward market. Decentralized market or bilateral trading. So bilateral means 쌍방 or 쌍무. So here we have two parties, the seller and the buyer. And the price is determined between these two. So there is no official price in this decentralized market. By contrast, decentralized trading, or this is known as pool trading, the system operator determines the market price. That's the key difference. So you can think this decentralized market, bilateral market, is very similar to the current stock market. So if you have some experience in stock trading, you may see the order book. Order book means there are offers to sell and bids to buy. Okay, and when there is a match between seller and buyer, then transaction happens and price changes. Okay, by contrast, this centralized trading requires a system operator, and that system operator in Korea is called Korea Power Exchange, KPX. So KPX is an independent system operator, okay, who manages this centralized market. Let's talk about this decentralized market first. And this bilateral trading is actually a classical form of trading. And the classical means this kind of trading have been happening for a long time, for a very long time, because it is very intuitive. The sellers has some quantity and the selling price, and the buyers have some quantity and the buying price. So typically, when you look at the order book looks like the seller's offer and the buyer's bid. So obviously, sellers want to sell it at a higher price, so they are placed here. Buyers wants to buy at a cheaper price. So when you look at the order book of a spot market, you usually see the price here and the quantity here, something like this. And so this is offer from sellers, and this is bid from buyers. And it changes real time in stock market. And suppose that this is $100. This is $99, and so on. Then transaction cannot happen because, right? Transaction cannot happen. The one who wants to buy is at most willing to pay this much. But no, if he or she really needs to buy that, this guy may want to grab this offer. Similarly, if this guy really wants to sell the good, then this guy can grab this offer. Then the price changes and transaction happens. Okay, so for every transaction, the price can change, and that's what is happening in current stock market. So this bilateral trading involves only two parties, seller and buyer, and this trading is private arrangement between these parties, and the price and quantity are negotiated directly between these two parties. So you need to look at this order book to make a transaction. So you can stay, wait, or you need to grab the offer or bid. Okay? So nobody else is involved in this decision, and actually this kind of bilateral trading is used in the standard European market. So Europe and the United States, North America typically have different systems for power systems, for communication systems, right? So in North America, the standard voltage for the standard low voltage is 110 volt. In Europe, that is 200 or 220. Okay, and what else? No, in almost all the technologies, they have different standards. North American standard and European standard. So ANSI is the standard for North America. Similarly, in Europe, ETSI standard exists. Okay? And we can observe that kind of thing in power system as well. So, yeah, bilateral trading is popular in European market. As I told you already, in bilateral trading, there is no official price, and this price changes for every transaction. And occasionally, this can be facilitated by brokers or electronic market operators. So this procedure is based on electronic market operators. And also it can take different forms depending on the time scale. So there are three types of bilateral trading. The first one is, so we are talking about forward market. So the first one is customized long-term contract. The customized long-term contract means, this customized means that, there is a seller, there is a buyer. Typically they are big guys. They want to trade a very large amount of electricity in advance using forward contract like Samsung Electronics. So customized and long-term contract. Long-term means this contract needs to be made in advance, like a few months in advance. Okay, and these contracts are very flexible because it only depends on two parties. So it only depends on their agreement. Nobody else is involved. Okay, so they need to. So this contract needs to be negotiated between two parties. Duration of several months to several years. It depends. It's quite flexible, and the advantage of this is that it guarantees a fixed price over a long period. Then you can, using this price, you can plan your business. Disadvantage, the cost of negotiation is high. The seller wants to sell it very high price. Buyer wants to buy it at a very low price. They need to negotiate. Okay? So this is because it has a lot of negotiation cost. It is worthwhile only for large amount of energy. Does it make sense? Actually, Samsung Electronics consumes a lot of electricity. So recently they hired, maybe 2 years ago, they hired PhD in the field of power systems because they need to buy a lot of power from somebody. And did I talk about PPA? Power Purchase Agreement? No. So PPA is PPA is a power purchase agreement between two parties, typically KEPCO who supplies the electricity, and the consumer. And this PPA is about a large amount of electricity, okay, for big consumers. The second type of bilateral trading is called over-the-counter trading, or OTC. This over-the-counter trading means, in Korean, this is called 장외 거래. Okay, so as you see from the naming, the volume of over-the-counter trading is smaller than before. Okay, so smaller amount of energy, and delivery can happen according to standardized profiles. Advantage, unlike these customized long-term contracts, it has much lower transaction cost because it is based on standardized profiles. Okay? And it is used to refine positions and delivery time approaches. And the third one is electronic trading, like this one, like stock market. So buyers and sellers enter bids directly into computerized marketplace, and all participants can observe the prices and quantities offered. But the ID is hidden. Okay? We don't know who sells, we don't know who buys. That is true in stock market as well. Okay? So in Korean, that is called 비식별화, right? And the automatic matching of bid and offer can happen because whenever this guy grabs that offer or that guy grabs this bid, the transaction can happen. And participants remain anonymous. And market organizer handles the settlement. Advantage of this electronic trading is very fast, very cheap. There is almost zero negotiation cost, right? When you change your mind, you can just grab that offer or bid. Here, two guys representing each party need to meet and negotiate. Hey, sell it at a cheaper price. No, buy it at a higher price. Let's negotiate, blah, blah. But no, in this case, we don't have that. And so the price in this electronic trading is a good source of information about the market. And every market participant can watch the price fluctuation. And so this is a kind of source of information about the market. And let's look at an interesting example of bilateral trading. And this is about a country which is called Bulgaria. This is an imaginary country, maybe perhaps in Europe. Okay, Bulgaria, power. And because Europe prefers bilateral trading, Bulgaria may exist in some Europe. So Bulgaria Power is a power generation company. Who wants to sell is power, and Bulgaria Power has 3 types of generation unit, A, B, C. So unit means power generation unit. So type A, based on large coal, minimum power 100 megawatt, maximum power 500 megawatt, and the marginal cost per megawatt hour is $10. Unit B, medium core, minimum, maximum, and marginal cost is higher than that. So, and this is a gas turbine based on natural gas. This is the most expensive one. So typically that's true. So marginal cost is a lot higher than that. But the advantage of gas turbine is that the minimum generation constraint, this is 0. So this is expensive, but it can immediately participate in the market if necessary. Okay? And also here we do not we do not consider the fixed cost yet, but typically, this guy has very low fixed cost, but high marginal cost. So, let's see. So, June 11th, 2 p.m. for 1 hour. This is the time period where we are considering for power exchange, the bilateral trading. And we have 2 long-term contracts that was made in advance, in January and February. Okay, so this is the buyer and this is the seller. So Bulgaria Power is a seller and the buyer is Ch3 Energy, Bulgaria Steel. You see, steel company like POSCO needs to consume a lot of energy. Ch3 Energy. I like this kind of naming, kind of cute. Anyway, so this long-term contract made 5 or 4 months in advance. And then, as time goes on, April, May, and June, this delivery date is fast approaching. Yeah, OTC, OTC, OTC. Quality electrons. Ch3 Energy again. And the amount of is like that. And as I told you, the long-term bilateral trading, the amount is typically very large compared to others. And yeah, the price is cheaper than that. Maybe this guy discounted the price. You purchase a lot of energy in advance, so maybe I can discount for you. Interesting part is this one. By the way, the slide, the PPT has changed. Some slide has been changed. So this is in your textbook. That is from the old PPT. So I replaced that with the new one. The textbook, the second edition was published in 2019, something like that. And Kershin revised the textbook a lot from the first edition. And in chapter 3, that's also true. Anyway, the interesting part is this one. Bulgaria Power is the seller actually, but this company buys the power. Why is that? This is forward contract. They want to sell it, but here they buy power this much. Why? This is an over-the-count contract. And anyway, the price changes over time. And the administrator of Bulgaria Power decides that he can buy, actually Fiona is the administrator of Bulgaria Power, with the textbook. Fiona, yeah, she is the one who decides to sell or buy at what price. And she decided that I can buy power and sell it later at a higher price. You see the price difference. So she wanted to take the advantage of the price fluctuation. Okay, May 13 and June 8. Anyway, so Bulgaria Power, totally, the sum of this is 600 minus 30, so 570 megawatt hour. This is the amount Bulgaria Power need to deliver on June 11th at 2 p.m. Okay, and time goes on. So January, February, April, May, June 8th, and yeah, the net position of Bulgaria Power is that they have committed to sell 507 megawatt, and their production capacity is 750 megawatt. You see that here, 750. Okay, and as time goes on, finally, today is the June 11th and mid-morning. Okay, and this is the order book. The pending offers and bid on Bulgaria Power Exchange at mid-morning on June 11th for the period from 2 to 3 p.m. So yeah, like KPX, Bulgaria Power has Bulgaria Power Exchange as an ISO. By the way, I told you ISO is responsible for centralized market, but here, this ISO is also responsible for bilateral trading. So, you see, this is the day, and this should be based on electronic trading. And you can see the offers to sell and bids to buy. And this is the identifiers. And this is the amount. This amount, you see that this amount are smaller than this quantity, right? And these are the prices. A very greedy seller, maybe he or she would not have a chance to sell at that high price. And a very greedy buyer, maybe he or she would not have a chance to buy. An interesting thing happened because Fiona, the administrator of Bulgaria Power Exchange, finds that so far I need to deliver 570 megawatt hour for 1 hour duration, but unit 2 has 200 megawatt capacity. You see there. Okay, so she thinks I have 130 megawatt more capacity to sell, right? And she is looking at this order book, and this is the price they are willing to pay. What was the marginal cost of unit B? That is $13. So she decides to grab these 3 offers, of which the price is higher than the marginal cost, 13, right? Yeah, so she has 130 megawatt more capacity, and this prices are higher than the marginal cost of unit B. So she decides to grab these 3 offers. That means she needs to deliver 60 megawatt further, right? So yeah, and she was happy before noon, but this is a mechanical system. Breakdown can happen, and she got a phone call from the engineer who is taking care of unit B. Hey, unit B has some problem. The maximum capacity is no longer 200 megawatt. It should be reduced to 80 megawatt because of some failure out of order. Okay, that means originally she needs to sell using unit B 70 plus 60 from here, but the maximum capacity that can be produced from unit B, B is 80. So 50 megawatt is in short. What can she do? She committed to deliver this much. How much? Using unit B, this much, but this is the maximum capacity that unit B can deliver. So actually she has 2 options. Well, just let it happen. let it happen, and see the spot, and see what happens in the spot market. Anyway, there is a spot market and the price fluctuations, and the amount of energy that cannot be fulfilled by Boldria power needs to be compensated at the spot market. So if the price is very high, then she will lose some money, or she can expect maybe the price can be low. So she can test her luck in spot market. That's option 1. Just let it happen. And option 2 is, again, using this bilateral trading. And so, yeah, this is the bid and offer in the afternoon. In the afternoon means that before 2 p.m. Okay. At 2 p.m., when there is a shortage or surplus, that should be managed in the spot market. But before, so that's option 1. Okay. But option 2 is, again, looking at this order book, and before this time, before 2 p.m. Comes, she found that other guys sell this amount of, so 50 megawatt is in short, and she finds that no other guys sell it at this price. And she decides to grab this offer. Because they are selling this energy, she buy it and sell it again to fulfill her requirement. And actually her anticipation is that this price would be lower than the spot market price. You see what I'm saying? Yeah. And at 2 p.m., what was the spot market price? I don't know. Anyway, the things goes in this way. Any questions? So do you want to do this kind of job? No? Why not? Like stock trading, you can trade electricity, and you can take advantage of price fluctuation. Maybe this job is too stressful. Okay.
유닛 B에서 이제 80메가와트까지밖에 안 돼서 50메가와트가 추가되는 거잖아요. 네, 위에서 보면 유닛 C에서는 맥시멈.
Yes. Okay, good question. So option 1, okay, relying on spot market. Option 2, using bilateral trading again. Option 3, turn on gas turbine. Good point. But this marginal cost is very high. So yep. So rather than using it, using the spot market would be better in this case. And actually I think she was happy because unit C, $17 marginal cost. This is a lot cheaper than that. Yeah, natural gas became more expensive, So KEPCO is not quite happy about that. And the government is not quite happy about that. You are not quite happy about that. So everybody is not happy about that. So whom should we blame for this? Anyway, any other questions? Okay, then let's move on to a new topic, which is about centralized trading. Centralized trading, there is a market operator, and sometimes ISO also takes this job. So all producers submit bids, and all consumers submit offers. You may think this is similar to that. Yeah, this is similar, but in centralized trading, using these bids and offers, the market operator construct the supply curve and construct the demand curve and find the intersection of these two curves to determine the market clearing price. Okay, so the market operator determines successful bids and offers and the market price. And this kind of market is typically used in North America. For example, PJM, in chapter 1, I showed you that there are maybe 13 ISO in North America, and one of that is PJM. PJM, Oracle, KAISO, what else? New York ISO, blah, blah, blah. And in many electricity markets, but the demand side is passive. That means actually, here we have offers from sellers and bids from buyers, but we typically have offers from sellers only, and there is no bids from buyers. So rather than allowing the consumers to bid their offers, these ISO or market operator do forecasting, load forecasting, and then the total amount of required power is estimated, and using that and using the producer's bid offers, you should be changing. The notation should be consistent when you write a paper also. Okay. So this is the example of centralized trading. You see another country, another imaginary country, Sildavia. Maybe in Sildavia there are a lot of rabbits. The reason is because Sildavia is similar to Sylvania. Sylvania, the toy is expensive. If you collect all the different types of rabbits and different types of house, blah blah, it costs a few $100s. You will see what I'm saying later when you have kids. Anyway, so these are bids and offers in electricity pool of Sildavia for the period from 9 to 10 on June 11th. So, yeah, offer, bid. These are the company, anonymous companies, and the quantity and the price. Interesting, because you see here, typically we are assuming offers and bids like that, and here the offering price is that much, and the bidding price is that much, and these guys are very willing to buy energy at a very high price, right? This is a lot higher than this thing. Okay, so you see a lot of overlap here. And the question is, how can the market operator can determine the price? So to do that, the market operator can construct. Okay, here we assume that the consumers, buyers also participate in the market. So using these two information, the market operator can construct these two curves. The first one is the supply curve. And how can you construct this curve? Well, you can sort 1, 2, 3, 4, 5, 6, 7 offers based on their price. Okay, so this is not sorted, but you can sort it and place them. $12, and the amount is $200, right? And then $13, $100. So 100, and next is $15, $50, 50, sorry, yeah, 50, and so on. So you see, you can think this is very similar to the marginal cost of the supply curve. Okay, and similarly, you can sort these bids to buy from the highest price and to the lowest price using this quantity. So this guy is very willing to buy very much, $200 at that much. So $25 and 200 megawatt, orange, yellow, purple, blah blah blah. Okay. And what is the market clearing price in this centralized market? How much? How much? Yeah, there is an intersection here. So this is the price. This is the market price. And this is the quantity that is traded. Okay, next question. What is the meaning of market price here? In this bilateral marking, in this bilateral trading, the price changes, and that depends on two parties. But here, this guy is willing to pay $25. This guy is willing to get only $12, and the market clearing price is $16. Then, this guy would be very, very, very happy. This guy is also kind of quite happy. Not quite happy, then orange guy. Anyway, happy. Not quite happy because they cannot participate in the market. So this is the profit of the producer, because this is the sale and this is the cost. Profit is reduced. This is the surplus of the buyer, as we discussed in chapter 2. Okay. Then you may think, why we need to have a single market clearing price, the common market clearing price for everybody. In bilateral trading, we have different pairs, and different pairs have different price. Because this is a centralized trading, we have a single market clearing price. Actually, there is a pros and cons for each scheme. Yeah, accepted bids and accepted offers. And let's look at one example. Here, the market price is the $16, and the volume traded is 450. Yeah, 450. And 1, 2, 3, 4, 5, 6. So these are the producers, these are the consumers, and you check their production quantity and the consumption quantity, and using the price, you can compute the revenue and expense. So revenue is before deducting the cost. Okay, so revenue minus cost is profit. So revenue, or this can be called sales, 매출. Okay. Okay, and here, in this example, we discussed the 1 hour period on June 11th. And then you may think this kind of centralized trading can happen for every hour. That can be true. But because electricity market needs to care about the physical system and the physical condition of the generators. So if we operate the centralized market independently from one time slot to another time slot, typically 1 hour, then that may require a lot of turn on and turn off the generators. But this turn on and turn off, you cannot do that arbitrarily, because it incurs cost, and also it can damage the generators. Okay. So rather than operating this market, centralized market, independently hour by hour, we need to have a concept of day ahead centralized trading. So day ahead, we want to determine what would happen next day, so that the generators can schedule their power generation. Okay, so So that's why we need to think about unit commitment. So what is unit? Unit is a power generator, okay? And unit commitment is that, okay. So now we are ready to talk about unit commitment. Well, this is abbreviated UC and economic dispatch. ED. So how many of you can distinguish these two? I know the difference. You should know. You are a doctor. 민재 probably knows the difference.
UC는 이제 발전기 기동 정지 계획, 언제 껐다 켰다 할지 전체 발전기에 대해서 스케줄링 하는 거고, 이코노믹 디스패치는 스케줄링 할 때 얼마나 경제적으로 운영할지 물리적 제약 조건을 제외한 채 계산.
Yeah. Neglecting network constraints. Then what? Okay, this is number one. This is number two. Then what should be number three? Optimal power flow. OPF. Well, actually, zero is the planning, construction planning. And also planning of the transmission line. Transmission lines, including distribution network and transmission network. So, yeah. In the previous example, its trading period was cleared separately, but we don't want to do that. The reason is because the operating constraints on generating units, it has minimum up and down time, and there is a lamp rate. That means you cannot increase very fast or you cannot decrease very fast. Okay, there is a lamp rate limit, and because there is startup cost and no load cost. Startup cost means that the generator is off and you turn on, then it incurs some cost. Okay, and no load cost means that even if when the generator is turned on and its output power is zero, still it has some cost, the fixed cost. And to reduce the risk of generators for each maintenance, it would be better to have schedule day ahead. So, yeah, so that reduces uncertainty on generation. So, yeah, we are talking about this unit commitment, and unit commitment needs to determine whether to turn on or turn off the generator. And because the variable we determine is a binary variable, binary decision variable. So typically, when the problem has this kind of binary decision variable, then the optimal solution is very hard to get, because when you have n binary decision variables, then to obtain the optimal solution, you need to check all the possibilities to the n cases. And when n is very large, as n grows, the complexity grows exponentially. But given the turned on generators, next job is to determine how much to produce to satisfy the total demand. In the previous case, 450 megawatt. That is very easy optimization problem, and that is called economic dispatch. The dispatch means, what is the meaning of dispatch? Dispatch means you cut small amount and put somewhere. Okay, so that's the dispatch. When you have some sore on your shoulder or neck, you can dispatch 신심파스 or something like that. Okay, so economic dispatch is that, but it typically neglects network constraints, the maximum voltage constraint and maximum power flow constraints. So in economic dispatch, we assume all the generators and all the loads are connected in a single bus. Okay, very easy problem. By contrast, this optimal power flow is the one is same to economic dispatch but with network constraints. Okay. So here we need to determine how much produced per generator, considering the maximum power flow and voltage limit, and also considering the network losses. Okay, all of those things are in the objective functions and constraints. Okay. 배가 고프군요. 배가 고파서 힘이 없군요. 배가 고파서 수업을 하기가 싫어지는군요. So, centralized trading using unit commitment. To do that, typically this is what KPX does every day. In 1 day ahead, they do load forecasting, and generators place their bids, and there are a lot of constraints about the generators, the minimum capacity, maximum capacity, the ramp up rate, and startup cost, and what else? The fixed cost and marginal cost. What else? Minimum duration when it is turned on, and the minimum resting period when it is off. Okay, so we have those constraints. And then using this information, the ISO solves the optimization problem. And this is non-convex optimization problem because of the binary decision variables. And then anyway, assuming that they obtain the optimal solution, there is a schedule, and the market price determined. And this market price, actually, we will talk about that later, but this market price is called what? So you may heard this terminology before, SMP. So if I need to select a few keywords, you must remember in chapter 3, SMP is the one. In chapter 1, ISO was that. In chapter 3, SMP is that. SMP stands for the system marginal price. And this is the market clearing price that is common to all the participants in the market. And this SMP changes over time based on the loads, based on the fuel cost, blah, blah, blah. Okay? And because of these days, the natural gas price is very high, this SMP is almost doubled, I guess. But KEPCO cannot change their electricity price. So that's why they are suffering from a lot of deficit in their finance. Okay. Generator bids. And all units, all generators bid separately, and components is the piecewise linear marginal price curve. Typically the cost function of generator is quadratic, so the marginal cost is linear. Okay, but piecewise linear. Piecewise linear, and the reason is because piecewise linear. And startup cost and parameters, the minimum megawatt, maximum megawatt, minimum up and minimum downtime. And the interesting thing is that typically when we talk about this economic dispatch and from optimization perspective, from system operators perspective, we assume that each generator honestly informs their cost structure, their marginal cost and fixed cost, so that the system operator can solve this economic dispatch problem, and then the SMP is determined optimally. This optimally means that it minimizes total generation cost in one country to supply the total demand. Okay? So that's the ideal case. That means the generator needs to honestly report their cost structure, the fuel cost. Actually, they cannot hide that because there is an open information. But generally speaking, in the centralized market, the generator need not bid honestly. That means the bids do not have to reflect their real cost. That is not enforced, and I think the reason is because how can I check it? This is not the right time to discuss that, but in power system economics, when there is a market, typically we do not have many players, right? In microeconomics, we assume competitive market when there are a lot of participants. But in electricity market, there are only a few key players, especially from the generator sides, right? So the world is not that beautiful. Each of them wants to maximize their profit. So they have their own bidding strategy, and they need not be so honest. Okay, and especially when there are only a few players, they want to exercise their market power. Exercise market power means that they can, they can distort the market to increase their revenue, profit. So this is a very complicated problem, and it requires the knowledge of game theory as well. Okay. But anyway, so and sometimes bidding very low to get in the schedule is allowed. So, hey, I cannot make money, but I want to get in. Somehow. The reason I don't know, but my boss asked me to do that, something like that. Anyway, generator bids, and because the customers do not directly participate in this market, the ISO does that job instead of the customers. So they do forecasting. Okay, so this is load forecasting. And so load is usually treated as a passive market participant. And here we assume that there is no demand response. So load changes, what is it? Lunchtime. Lunchtime is coming. We are all hungry. And based on this load forecasting, in each time slot there is a load to satisfy using generation, and then this is the generation schedule. You see different colors here. Different color may mean different types of generators. Okay. Typically, these are nuclear power plant. When they are turned on, you cannot turn it off. Of course, you can turn it off but then you need to wait a few months to turn it on again. Okay? And also you cannot change the output power generation. It is constant generation. That is true in Korea, but that may not be true in some other country. They have some techniques to change the output power. I heard that, but that is not quite recommended. Anyway, so we have power generation to cover this base load. Okay, base load means 기저부하. And next. So this part is the one when there is the highest load, and obviously that means the price at this time slot is the most expensive. And the reason is because when we have this kind of supply curve and the demand changes over time, then the sometimes market clearing price is here when the load is low, and when the load is high, the market clearing price is that much. Okay, so assuming the generator, the bids are same, when the load changes, the price changes. So during this peak load period, obviously, the SMP is high. So in Korea, we have two types of electricity price plan. The one is for, we have many options, but simply, roughly say, we have two different types. The first one is for industrial and commercial building, based on time of use, TOU, where the price changes over time. And the price changes comes from the SMP changes. So SMP changes is reflected in TOU, time of use. I don't quite like this terminology. What is time of use? There is no price here. What? Anyway, so everybody says this, TOU, okay? But another types of customers are residential customers like you. So in the case of residential customers, previously, we have a lot of residential customers, maybe 20 million or something like that. But in terms of industrial and commercial buildings, the total number is a lot smaller than that. So KEPCO could place the meters that measure the power consumption of these guys every 15 minutes. Okay, that was already installed long time ago. That's why they can use this POU, these commercial and industrial customers. By contrast, for residential customers, 10 years ago, and still some apartment and common residential units, a man need to go out and read the mechanical meter. This mechanical meter rotates. Actually, I have that meter in my previous office, K237. Okay, when I turn on the air conditioner, it runs very fast and slow. And if I have a solar panel, it slowly and stop and rotates counterclockwise. So when I generate, it rotates back. Okay. So anyway, using this mechanical smart meter, man can read the number one time per month, and then the total the fee is charged based on that number. So actually, whether the time slot is 15 minutes or 1 month, even though we have different time scales, we can say, yeah, they are similar, but this time difference is huge. Okay. Anyway, so as I told you, each time slot, different units. Each time slot we have different loads, so different units need to run, and the most expensive units needs to meet the load at each period. So SMP is determined from the most expensive unit. Okay, and all other cheaper generators can be better off. And yeah, market price, I already told you. Bid from the marginal unit sets the market clearing price at each period. That is called system marginal price, SMP. And all energy traded through the pool during the period is bought and sold at that price. Okay, so let's check. Let's check what is the current SMP in Korea. Well, typically, you need to remember the SMP is typically 101 per kilowatt hour. Okay, but I'm not sure what that is at this moment. 누군가를 선택해야 한단 말인가? 막 선택해도 되는 건가? Yeah, this is today. 24 hours. One time slot is 1 hour. And this is today. Wow. Yeah, this is a lot more expensive than I told you. No, all of them are more than 101. Very expensive. And actually that was more expensive on this day. Last Friday, more than 250. Wow. Okay, it depends on the total load. Okay. So maybe this is the last slide. Why do we need to trade all energy at the same SMP? And to make a long story short, if we ignore the startup cost and the fixed cost and just considering this economic dispatch, then using a single price SMP and to pay all the generators using that SMP is the one that minimizes the total generation cost. Okay, that is from a simple optimization, convex optimization problem solution. But we have some words here. So why not pay the generators what they bid? First, cheaper generators would not want to leave money on the table. What does that mean? The generators would try to guess the SMP and bid close to it. That means they do not bid honestly. So here, for the most basic, naive, and idea case, we assume that generators bid honestly. Their marginal cost is the real cost. Okay, using SMP encourages them to bid honestly, truthful bidding. That is called truthful bidding. Otherwise, they try to guess SMP and bid close to it. And occasional mistake, then the generators can get out of the schedule, get left out of the schedule, and that increase the uncertainty, and this increased uncertainty increase in price. So let me stop here, and on Wednesday we will talk about the optimization case.